Hi, hello. My name is Andrew Lake. For this video, we're going to go over how to find the area of polygons created in a coordinate plane by a system of points. In order to do that, you're going to have to go through three steps. The first step is we are going to have to be able to graph the points. Remember, these points are in X, Y order. So this first number is your X, second number is your Y. So to plot this point, I would go right 2 and up 1, and that would give me the point 2, 1. To plot my second point here, I would go right 2, down 3. That would give me the point 2, negative 3. And then this last point, I would go left 1 and down 3, giving me the point negative 1, negative 3. If I then connect those uh, with straight lines to make a polygon, I get a right triangle. Let's try that bottom one again. There we go, a right triangle. Uh, and then the next thing that we would have to do after plotting those points and connecting them to make a polygon is to find the area of that polygon. What I mean by the area is the shaded area, the shaded region inside this triangle that's bound by these three lines. I want to know how large that region is. In order to find that, the easiest way is to identify what shape you're dealing with and then find the formula for that shape. So our shape is a right triangle, and to find the area of any triangle, you can do 1/2 of its base times its height. So for our triangle, the base and the height are going to be pretty easy for us to find. We can just count. So from negative 1 to 2, the length of this base is going to be 3. From negative 3 up to 1, the height of this triangle would be 4. So for our triangle, we have a base of 3, a height of 4, and so the area of our triangle will be 1/2 of 3 times 4, which is 1/2 of 12, which is 6 units squared. So the area of our first shape here is going to turn out to be 6 units squared. And again, you find that by plotting the points, connecting them to make a shape, and then identifying what that shape is, finding the formula for that shape, and then plugging in the numbers for that formula and calculating it. For number 2 here, I'll show you that same method plus an additional method that you could use when you get a slightly more complicated shape. Again, we're going to start with plotting. So I'm going to plot these 4 points. This first point, I would go left 3 and up 5. 1, 2, 3, 4, 5. That's the point, negative 3, 5. Second point, I would go right 4, up 5. Third point, I would go right 5 and over 0, or up 0. And then the last point, I would go left 4 and up 0. All right, if I connect those to make a quadrilateral, it's going to turn out that this quadrilateral is a trapezoid. It has a pair of parallel sides, and the other sides are not parallel. So if I want to find the area of a trapezoid, I could Google what is the formula to find the area of a trapezoid, and you should get that is 1/2 of b sub 1 plus b sub 2 times h, where b sub 1 and b sub 2 are the bases, um, and those bases of a trapezoid are the sides that are parallel to each other. So these are my two parallel sides. So I could say this bottom parallel side is my base sub 1, and this top is my base sub 2. It doesn't really matter which one you call b sub 1 or b sub 2. You just have to make sure that you're labeling the parallel sides as your bases. And then the height of a trapezoid is the distance between those two bases at a 90-degree angle. So how far apart your two parallel sides are. So for our trapezoid, this bottom length from negative 4 to 5 would be 9. The top length here from -3 to 4 would be 7. And then the distance between my two parallel sides from 0 to 5 would be 5. So if I plug those three numbers into my formula here, I would get that the area of my trapezoid is 1/2 of 9 plus 7 times 5, which is the same thing as 9 plus 7 is 16 times 5. 1/2 of 16 is 8 times 5 is 40 units squared. Okay, that's great if you are able to look up the formula or if you have the formula memorized. But let's say for some reason you aren't able to look it up and you don't have it memorized. Like, for example, you're taking the ACT and it just blanks for you. Another way you can find the area of a shape like this is to break it up into smaller pieces you do know how to find the area of. So, for example, I could split and set this as a right triangle right here. Same thing on the right side, make this a right triangle right here. And then in the middle now, I would have a rectangle. And those are usually, I feel like students have a better, are more comfortable with finding their area. So each of these triangles, I would find their area by doing 1/2 base times height. The area of my first triangle has a base of 1 and a height of 5, so it would be 2.5. There, my second triangle is the same thing. It has a base of 1 and a height of 5, so it will also be 2.5. And then the rectangle that I have left over would be a 1, 2, 3, 4, 5, 6, 7 by 1, 2, 3, 4, 5 rectangle. And to find the area of a rectangle, it's just length times width or base times height, which for us would be 7 times 5 or 35. And if you then add those three numbers together, if you add the area of those three shapes together, you get the total area, which is 40, which notice is the same thing we got over here. So the area of this trapezoid is going to be 40 square units. Ideally, if you can identify what shape it is and then find a formula for it and use that, that's great. If you can't, or maybe it'll just be easier for you, you could break the polygon up into smaller shapes and find its area. So let's try using that technique on this next problem. Here is a shape that you will not be able to look up and find an area for. But what I would like you to do is break it up into smaller pieces in order to find the area of the shape. And here, let me label all of these for you. Okay, so what I'd like you to do is to try to break this shape up into smaller shapes that you can find the area of, and then add the area of those smaller shapes together to find the total area of this polygon. Go ahead and pause the video and try that on your own, and then if you resume, you should see the answer in 5, 4, 3, 2, 1. All right, so hopefully you got that the total area was 108.5 units squared. You didn't have to break the shape up like I did. If you broke it up like, let's say, vertically here, that's perfectly fine. But if you did break it up like I did, you should get this triangle right here is going to have area of base times height divided by 2. Its base is 5, its height is 5, so you're going to do 25 divided by 2, which is 12.5. That leaves you with this tiny little rectangle here, which is a 5 by 1 rectangle. So its area is 5. And then that leaves you with this last third shape is a big rectangle here that goes 13 by 7. So you should get a total area then 13 times 7 is 91, plus 5 plus 12.5 is 108.5. Okay, let's try one more of those. So for this problem right here, again, see if you can find the area. Shin thinks that the area is 13 square units. See if you can determine whether or not Shin is right or wrong. You should pause the video, and then if you resume, you should see the answer in 5, 4, 3, 2. All right, hopefully you got that Shin was not correct. If we go through the math here, to find the area of this shape again is probably not easily to do through a formula. It's probably easier to find this one by breaking it up. I broke my shape up like this. Again, you could break it up however you like, as long as you're then able to find the area of the smaller pieces. So the top portion here I made into a trapezoid, which had a base of 6 and 4 and a height of 1. So I did a half of 6 plus 4 times 1, which is a half of 10, which is 5. And the reason why I broke it up as I did is because that third region down here is the exact same shape. So I didn't have to do any more calculations. Its area would also be 5. And that leaves me with this middle region, which is a rectangle. It's a 6 by 4 rectangle, so its area is 24, which means my total area is 5 plus 5 is plus 24, or 34 square units. Hopefully you found this video helpful, and if you have any questions, again, if you post them in the comments, I might be able to answer, but you also just always ask your math teacher. All right, thank you very much, and have a good one.